Hey guys, it's Miss Perenboom here, and we are going to be looking at Learning Target 9G, which is on the volume of prisms. Okay, so since this is our first lesson that involves volume, let's start by talking about what that even means. Now, we just spent the last 2 days talking about surface area, and I kind of like to think of surface area as like wrapping a present. So if you were to put all the stuff in a box, surface area is kind of like how much wrapping paper do you need in order to cover the entire box, right? Okay, but then volume is sort of like what fits inside of the box. So volume is talking about the measure of the amount of space that a three-dimensional solid occupies. Okay, now because this is going to be a three-dimensional measurement, we're going to be using cubic units. So with area, we always use square units because area is a two-dimensional measurement. So volume being three-dimensional, we're going to use cubic units. So for example, cubic centimeters, cubic feet, etc. We write it by using an exponent of 3 at the end of whatever units we're measuring in. So cubic, centimeters, and so on. Okay, another way I like to think about volume is of giving the area of a shape thickness. So think, for example, about a single sheet of paper. If you had a single sheet of paper, you could find the area of that sheet, but the thickness is so minimal, right, that it's almost like non-existent. But then as you start to stack page after page, you eventually get this stack of paper, and then that starts to resemble a rectangular prism. And so if I found the area of a single sheet of paper and then I multiplied it by like how tall that stack of paper is, right, like the height, then that would give me the volume of that like rectangular prisms that's formed. So again, to sort of recap that, we want to think about multiplying the area of the base by the height of the solid. Okay, so today we're only going to be focusing on finding the volume of a prism. Now remember that some prisms are going to be rectangular, some might be triangular, and so on. To be a prism, though, you have to have two congruent parallel bases. So that means that, like in a triangular prism, there's two triangles. They're the same size, they're opposite each other, they're parallel to one another, and then they're connected by rectangles. In a rectangular prism, technically you can pick any pair of opposite rectangles to be the base, and then, again, the other rectangles connect them. So our formula for volume of a prism is going to be capital B, which stands for area of the base, times h, which is the height. Now remember, capital B, area of the base, that means you're doing some sort of calculation to get the area of that flat two-dimensional shape, and then you take that measurement times the height. Okay, so let's start with this first one here. All right, this is a rectangular prism. I have a length of 12 inches, a width of 4 inches, and a height of 5 inches. So the first thing I'm going to do is I'm going to identify my base shape. So I'm going to use this rectangle that's down here sort of on the bottom, right? This one is going to be my base shape. So if I wanted to get the area of that base rectangle, I would do length times width, so 12 times 4. Once I get that area, I now have to make it three-dimensional, so I'm going to multiply by the height, and height is always going to be the distance between the two bases. So from the bottom straight up to the top, right, that's going to be considered my height, so in this case 5. So when I go to fill out my formula, again, capital B, area of the base, was found by doing 12 times 4, which is 48. I'm going to multiply that by the height, which is 5, and that's going to give me a total of 240 cubic inches. All right, let's take a look at another one. So here's another rectangular prism. This time I've got a length of 12 inches, a width of 8 inches, and a height of 2 inches. So if I start by identifying my base, I'm going to use this one that's sort of already colored in red here. Okay, this is going to be my base shape, which means that the area of that rectangle can be found by doing 12, which is the length along here, times 8, which is the length along this edge. So 12 times 8 gives me the area, and then the height has to be from the base across to the opposite side. So the height then is going to be 2. So 12 times 8, that gives me my base area, which is 96. Multiply that by the height of 2, and that's going to give me 192 cubic inches. All right, now, not every prism is going to be rectangular. In this case, we have a triangular prism. And so my base shape here in red is going to be the triangle. Okay? And so when I think about my formula, area of the base times the height, I need to consider how do I find the area of a triangle. And so if you remember back from the beginning of chapter 9, we're going to be doing the base times the height of the triangle and then divide by 2 or take half of it. So half of, in this case, 3 times 4. So when I just focus in on the triangle, I don't really need this 10 at all, right? I just need this side length and this side length because they were perpendicular at a right angle. So half of 3 times 4, that's going to give me the area of the base. Now the height has to be the distance between my 2 triangular bases. So from here all the way across. So that actually tells me that my height is 10 meters. So height is not always necessarily going to be from the bottom straight up, right? Height is defined as the distance between the bases. Okay, so when I plug in, again, half of 4 times 3, that gives me the area of the triangle, times my height of 10. Well, I know 4 times 3 is 12, so half of that's 6, and 6 times 10 gives me a total of 60, and this would be cubic meters. All right, with this next one, okay, I have a pentagonal prism. Okay, so first let's think about what's the base shape. Okay, I'm hoping everybody answered pentagon, right? So I have 2 pentagons, one on top, one on the bottom. Those are going to be my base shapes because they're the same, they're congruent to one another, they're parallel, and they have rectangles connecting them. So we don't have a formula for finding area of a pentagon. We haven't learned that yet. However, look what's given to us here. Our base area, capital B, is said to be 172 square inches, right? Because it's area, so it's square inches. So then I just need to know my height so that I can plug into my formula. So the height would be, again, the distance between the 2 pentagon bases, which means my height is going to be 5. So when I plug in base area of 172 times the height of 5, that gives me a total of 860 cubic inches. All right, and I'm going to give you this last one to try on your own. So first, I want you to determine what is the shape of the base. Okay, I'm hoping you said it was a triangle, and so if you are looking at your triangular base here, okay, the first thing I want you to calculate is the area of that triangle. So what is the area of that triangle going to be? Okay, now that you have the area of the triangle, we're almost ready to find the volume, but we have to first know what's the height. And so I want you to identify what are we using as the height of the prism. All right, and so height, hopefully you said, is that distance between the bottom triangle and the top triangle, which would be 6. That's my height. And so for the area of the base, hopefully you had done half of 12 times 8, which is going to be 48 times that height of 6 for a grand total of 288 cubic millimeters. All right, so before we go here, please fill out these last 2 prompts. So I learned or was reminded of, and questions I have are. So try to write one thing for each, at least one thing for each, I should say, and then we'll see you tomorrow. Thanks for watching.